Welcome to the OTech Talks podcast, where it's all about working on technologies. You will hear the latest tech information, and your host, Kashif Manzoor, brings together product overviews, how-tos, best practices, tips and tricks, and troubleshooting techniques.
Machine learning is an application of AI that can automatically learn and improve from experience without being explicitly programmed to do so. The machine learning occurs as a result of analyzing ever-increasing amounts of data. Let's go and listen. So, good morning, good afternoon, good evening, wherever you're based. Have a blessed and wonderful life. This is your host, Kashif Manzoor, with a new session on OTech Talks podcast. Today's session number is 82, and we will be discussing the machine learning's basics, which we started from session number 80, where we had what is machine learning, very initial for beginners guides, and now how it's gonna work. That's is topic for today. If you're new to the show, welcome to otechtalks.tv. If you are a regular listener, thank you so much for listening and being with me. This is our journey together where we are learning and improving ourselves based on the knowledge, based on the experience which we are getting on day-to-day basis. OTech Talks, Open Tech Talks is your weekly sandbox for technology insights, experimentation, and inspiration with the primary objective of learning and sharing. Now, according to the book, if you're new to the machine learning, to recap the basic definition of, according to the book Foundation of Machine Learning, second edition, machine learning can be broadly defined as a computational method using experience to improve performance or to make accurate predictions. When they're talking about experience refers to the past information available to the learner, and which typically takes the form of electronic data collected and made available for analysis. This data could be in the form of digitized human-labeled training sets or other types of information obtained via interaction with the environment. In all cases, its quality and size are important to the success of the predictions made by the learner. And as we discussed in the previous session, there are types of machine learning commonly, or the algorithms or building blocks, which we talk about. And those are supervised learning, unsupervised learning, where we spoke earlier in the session. If you're new, I think we would suggest you should go back to the session number 80, where you will learn the very basics, beginner's knowledge on the machine learning. Today, our focus is how machine learning is gonna work, or what are the steps which are typically involved in the machine learning from point of view. Now, definitely, there are certain steps that machine learning algorithms need to make, and the first step is, we will go in detail, but I'm just gonna start from that angle. That the steps, select and prepare a training data set, right? That's step one. Now, then the step two is choose an algorithm to run on the training data set, and then step three is, which they are talking about, training the algorithm to create the model. And then step 4, using and improving the model. Now we'll go after a few minutes on these 4 steps. However, we just want to start with, from these 4 basic steps. Now, they're typically defined, or who's defining or who's implementing these steps. Nowadays, number of new software packages, they started coming with the built-in machine learning algorithms or machine learning steps. Otherwise, the data scientists, data engineers, they are doing all these steps to perform, who have the knowledge and expertise on to run the machine learning. Now, these steps, which are form of, definitely the computational algorithm, these are at the core of making determination, right? Then the variables and features that make up the decisions, and the basic knowledge which enables or to train the systems to learn. The model is a parameter, it's a data for which the answer is known. Now, before we will go to these 4 steps, Just for on a high level, the machine learning has commonly we're talking about supervised learning and unsupervised learning, and my target is that in the next session we will go in detail on the supervised learning and unsupervised learning primarily. But in the supervised learning, there are common, classification, regression types. Unsupervised learning, which is talking about clustering, and then we will see, k-means, linear regression, naive Bayes, nearest neighbors. All these are different techniques which are used in the machine learning algorithms to use it. Now let's go, and now we will directly target our 4 steps, which are basically parts or the building blocks of how machine learning is going to work or is working. The first step is select and prepare a learning or training data set. Now the training data is actually a data set representative of the wider or the bigger picture or of the data, which machine learning model will ingest or to enter, to input to solve the problem it's designed to solve. We have billions of record of data, and out of that data we want to have some sample data or training set data. That data we will input it, and then it will give us designed to solve the problem. In some cases, the training data is labeled data, or we are talking about tagged data. That's how machine learning, even sometimes talks about that labeled data or unlabeled data. So when it's a labeled data, is tagged data. To call out features and classification, the model will need to identify. Now, other data is unlabeled data, and the model will need to extract those in features and assign classifications on its own. So there is, when we say supervised, unsupervised, then again, this is in a common language, it's a labeled data and unlabeled data. Now, some other cases where the training data needs to be properly prepared, randomized, or checked for imbalances or biases that could impact the training. It should also be divided into subsets. The training subset, which will be used to train the application or the data set, and the evaluation subset, it's used to test and refine it. That's how labeled data, unlabeled data, when we're talking about preparing the training data set. Step 2 is choosing an algorithm to run on the training data set. Now, algorithm is is statistical processing steps. The type of algorithm depends on the type of labeled or unlabeled data and amount of data in the training data set which we want to use to solve the problem. And when we say labeled data and unlabeled data, for example, in the labeled data, which is talking about labeled data, when we say it's a supervised learning, right? It has classification, it has a regression. In the classification, it has support vector machines, it has naive Bayes, nearest neighbor, linear regression, SVR, GPR, ensemble methods, decision trees, neural networks. Now, let's go first on the regression algorithms. Linear and logistic regression are examples of regression algorithms used to understand relationships in data. Linear regression is used to predict the value of dependent variables based on the value of an independent variable. Logistic regression can be used when the dependent variable is binary in nature, for example, A or B. And a linear regression algorithm could be trained to predict a salesperson's annual sales. For example, the dependent variable based on its relationship to the salesperson's education or year of experience, the independent variables. Another type of regression algorithm called a support vector machine is useful when dependent variables are more difficult to classify. Decision trees uses classified data to make recommendations based on a set of decision trees. And we will go in detail, frankly, in the supervised learning, that how these instance-based learning algorithms or decision trees or regression algorithms are working. So that's just in this very high level. And when we see unlabeled algorithms or unlabeled data, when the clustering algorithms, think of clusters as the groups. Clustering focuses on identifying groups of similar records and labeling the records according to the group which they belong. So in that one, there's some number of techniques are available, association algorithms. So these are different techniques which are available. We will go in detail. Now, we understood the step one from is selecting and preparing a training data set, choosing an algorithm to run on the training data set, and these selection of algorithm is depend on a number of factors. When we say dependent, independent variables, labeled, unlabeled, all techniques which we need to keep in mind. So this means we should have a fair and very good understanding on the techniques and the algorithms, how algorithm works, what are the basics behind it. And that's where we are going to go in the next session to go in depth on that one. Now the third step is training the algorithm to create the model. When we're training the algorithm is an iterative process. It's not just one time, right? It involves running variables through the algorithm, comparing the output with the results it should have produced, adjusting weights and biases with the algorithm that might yield a more accurate result, and running the variables again until the algorithm returns the correct result most of the times. The resulting trained or the trained accurate algorithm is the machine learning model. The final one, which you have decided it that yes, now this is most of the cases it's close to that one. And that's important distinction to note, that algorithm and model are sometimes it's interchangeably in the machine learning we can use that model or algorithm. Now once you're done with the training the algorithm, you need to how to improve the model. That's the last step. It's keep improving it, and that's the final step in the use the model with the new data. The final step is to use the model which you developed based on the training or the learning data set with the new data, and in the best case for it to improve its accuracy and effectiveness over time. Where the new data comes from depend on a number of factors, but what you do is you put this model which you trained from the training data set on the new data set, and then you see what is the percentage of success of the model, or most of the cases, or how many cases it reached to the correct output when it was doing on the training data set. For example, a machine learning model assigned to identify spam will ingest email messages, whereas a machine learning model that derives a robot vacuum cleaner will ingest resulting from real-world interaction with moved furniture or new objects in the room. So these are some of the examples that if you want to identify the spam emails, and then definitely how many spam emails or what type of spam emails are coming. Now there are a number of real-world examples on these one. Digital systems, recommendation systems, contextual online advertising, chatbots, fraud detection, cybersecurity, medical image analysis, self-driving cars. All are the common examples of these classification or algorithms are being used from the machine learning point of view. Now, definitely, the whole objective of is to train the machine learning model until the algorithm it generates provides accurate results for a reasonable percentage of the time, or some approximation on that one. And at that time, that you will implement the machine learning model into real world product, so real world data, and then you will assess it that okay, based on this real world or full data set, how it behaves, how it performs. And then definitely over the time, the model interprets more and more data from the outside world. Its accuracy will decrease. And then because it's encountering a new kind of data, or it is going to make more errors. So with this one, that as a data scientist or as an owner, then what you will do, you will keep repeating the training process to increase the model's accuracy. So that's how it keep repeating it, and it keep improving it. and from the way you will keep getting exposed to the new data set. So let's take another very common example, which I thought it is a common or relate to everyone. It's a Facebook, right? And now take an example. How does Facebook decides which ads to show to people? Now, first, advertisers. If you want to advertise, you need to choose the target audience. Like, for example, their gender, age. So based on different parameters. Right, and then they have the auction stage where they want to give a person who is going to advertise it the value score or value and ad quality. So they define, okay, total value is equal to advertiser bid multiplied into percentage estimated action rate plus ad quality. So these are some of the factors. Take an example. Now, how machine learning or what machine learning works in this situation. That, okay, the machine learning, the way Facebook is using is an system that learns as it receives new data without being explicitly programmed to carry out complex tasks quickly and efficiently. Now, Facebook uses machine learning to generate the estimated action rate and the ad quality score used in the total value equation. To find the estimated action rate, machine learning models predict a particular person's likelihood of taking the advertiser's desired action based on the business objectives the advertiser selects for their ad, increasing visits to their website or driving purchases. For example, the Facebook's model considers that person's behavior on and off Facebook, as well as other factors such as the content of the ad, the time of the day, and interactions between people and ad. Examples of behaviors on Facebook that the models consider include things a person does while using Facebook apps, like clicking on in or liking a post. Examples of behaviors off Facebook that models consider including things a person does outside of the Facebook that businesses share was via like business tools like visiting a website, purchasing a product, or installing an app. So to generate an ad's quality score, machine learning models consider the Facebook feedback of people's viewing or hiding that, as well as assessments of low quality attributes like too much text or ads and image. So now over time, more people view an ad. Facebook got a feedback on it or click through to make a purchase on an advertiser's website. Our Facebook's model get better at predicting the estimated action rate and ad quality. Now, definitely billions of people use Facebook, so that data is enormous data. So they get a lot of information on it based on if you're clicking, you're viewing it. That's how they are predicting that their machine learning model is working, and then it's keep improving it to show you which type of ad based on the advertiser's chosen parameters. That's how even Facebook is using it, and I will put it in the show notes if you want to go into more detail on how Facebook is using just machine learning to display the ads for you. With this, I think we are done with how machine learning works. There were 4 basic steps. And in the next session, we will go on in detail on supervised learning and unsupervised learning, clustering, classification, regression, what are the tools in a very detailed algorithm techniques, so that we will keep learning and improving our journey of as a beginner's guide to machine learning. Thank you so much. Have a blessed life.
Thanks for listening to the OTech Talks podcast, and be part of Tech Talks at otechtalks.tv. It's a turf to share ideas, insights, and innovations.